Hey guys, in this video we're going to be talking about subtracting rational expressions. Essentially it's addition, but one small extra step. So the first thing that we're going to do is we're going to get both fractions with a common denominator. Once again, every example in this video will have a common denominator. I'll be making another one when they don't, but just make sure anytime you see an addition or subtraction sign, you always try to make sure that that happens. Second step is you're going to change to an addition problem. And what you're basically going to do is distribute the negative to the numerator of the second fraction. So kind of like when you have a negative outside of parentheses, you're just going to distribute it to every term. Then you're going to add the fractions. Remember, that's only in the numerators. Once it's one single fraction, you're going to factor the numerator and denominator. You're going to simplify, and then as always, I can't stress enough, don't forget excluded values. All right, so let's take a look at this first example. So step number one that we always want to make sure we do is we want to change this to an addition problem. That means this becomes a plus and minus and minus. From here I have common denominators, so I can go ahead and combine my like terms. I have 9x plus 12 minus 7x minus 2 over 16. Or when I add everything together, 9x and negative 7x, that's going to be 2x. 12 and negative 2 is plus 10 over 16. Remember, once you're as a single fraction, we're going to factor where we can. I have a GCF that I can take out of the numerator. So that's 2 times x plus 5 over 16. And then from there, 2 and 16 are both divisible by 2. So the 2 becomes a 1, which I don't need to write. And the 16 becomes an 8. This is x plus 5 over 8. We eliminated a 2 from the numerator and the denominator, but because there's no variable with that, we don't have any excluded values in this case. All right, second example. I have a common denominator, so I'm going to change it to addition. That becomes plus, and then negative 16m squared. So this is 1 minus 16m squared all over 12m minus 3. First thing that we're going to do is we never like to see our biggest term. So in this case, our biggest term is this 16m squared because it has the greatest exponent. We never like to see that negative. So what we're going to do first is we're going to take out a negative 1 from the numerator. That becomes positive 16m squared, and then minus 1. And in the denominator, I can take out a GCF of 3. That becomes 4m minus 1. You might be looking at what's in the parentheses of the numerator and kind of confused on how to factor it. What you should notice, 16m squared and 1 are all perfect squares. We have the difference of 2 squares because it's subtraction. So we talked about this in an earlier video. When you factor with the difference of 2 squares, you need 2 sets of parentheses, one with a plus and 1 with a minus. What squared gives me 16m squared would be 4m, so that comes first in both of them. And what squared would give me 1 is just 1 in both of them. All over 3 times 4m minus 1. From here, all I'm going to do is cancel where I can. So 4m minus 1 cancels with 4m minus 1. You're going to be left with negative 1 times 4m plus 1. Typically, we don't really like to see that negative 1 on the outside. I'm going to go ahead and distribute it. That's negative 4m minus 1 over 3. Remember, if you're struggling with the excluded values, all you have to do is take whatever you've crossed out and set it not equal to 0. So I add 1 to both sides. 4m equals positive 1. Cannot equal positive 1. Divide by 4. M cannot equal 1/4. So you list your excluded value as m cannot equal 1. And lastly, once again, first step, you want to change this to addition. So that becomes plus, minus, and 9. I'm going to combine w squared plus 3w minus 7 minus w minus 1 over w squared plus w minus 6. Combining our like terms in the numerator, we're going to get w squared plus 2w minus 3. Denominator once again staying the same. Now, whereas a single fraction, we can factor. Both times it's going to be trinomials, so we're factoring to binomials. Since w squared is the first term in both of them, we know every parenthesis is going to have a w at the beginning. Numbers that multiply to negative 8 and add to positive 2, that's positive 4 and negative 2. And the numbers that multiply to negative 6 and add to positive 1, that's positive 3 and negative 2. From here, we can cancel the w minus 2 to get w plus 4 over w plus 3 with an excluded value of 2. Remember, I see a lot of people that think I have a w in the first position of both numerator and denominator, I can just cancel them. You cannot cancel within addition. Division does not go with addition. It only goes with multiplication. So in this case, this is your final answer.